I can't hear it. I'll go get another speaker. I have some downstairs.
It is our pleasure to have Dr. Krestow here with us today. She received her Bachelor of Science in Astronomy and Physics, Master of Science in Geophysics, and her PhD in Physics at the University of Toronto. She's passionate about astronomy and helping students better understand the universe that they live in. professor at the Glendale Community College, and she's here today to share with us Tales from the Trenches, teaching astronomy at California Community College. So welcome.
Thank you. So it's interesting that I'm here teaching about teaching, so to speak. I'm somewhat in awe because I'm at Caltech. And I've been on campus before, and it's a lovely campus, but my students aspire to get here one day, and I told them I was coming. They were very jealous, so I'm very pleased to be here. So I wanted to give you a little bit of an outline of what I'm going to kind of cover in the talk. I'm going to explain sort of who I am and where I work and what I do kind of on a daily basis, and then how I do what I do, which I like to call, and we physical scientists at my college call tricks of the trade. And then, more importantly, what I've learned from my students. Because you, as teachers, hope to teach your students stuff, and you hope that they learn from you, but there's a lot that you can learn from your students. And these are kind of tales from the trenches, all the stuff, all the interesting things that I've learned from my students and how that affects my teaching. Then I'll give some recommendations if you are interested in going into teaching, and also kind of draw some conclusions. So a little bit of background that I want to start with. How many of you, because I imagine you're here because you're possibly thinking about career, but how many of you have taught your own class before? So not TA, but taught your own class. We have a couple of teachers here. How many of you are hoping to teach your own class in the next 5, 10 years, something along those lines?
So for us, that means keep your job.
Yeah. Okay. So some of what I cover today may kind of percolate in the back of your brain over the next few years as you're contemplating getting your own teaching position. So one of the things I want to do in this class is kind of set the tone. If you have a question at any time during the presentation, please don't hesitate to ask. It's a lot more interesting if the class is interactive than if you're just sitting there drinking your coffee and eating your cookies and listening to me and doing the Facebook thing, surfing the web and whatnot. You'll get a little more if you actually tune in. Anyway, a little bit about who I am. My name is Jenny Krestow. I do have a PhD from the University of Toronto. And if we were talking as colleagues, kind of like scientist to scientist, I'd tell you that my PhD was associated with developing a new analytical technique using accelerator mass spectrometry for measuring sub-ppb levels of platinum group metals and insulating samples and yada, yada, yada. That's all great and good, but my students don't care what I've done. They really don't. I say that to them and they're like, huh? They kind of get that glazed over look. That glazed over look is very common in a first year class, I think probably wherever you teach. So one thing is if you are interested in going to be a teacher at a community college, certainly in California, be aware that that whole academic prowess and ego that you have won't work at a community college because there are no research facilities at any of the California community colleges that I know of. And that's because there's no money for it. And you're busy doing other things. So my students don't really know me as a scientist. They do know me as Professor Jenny Krestow. I try and get them, I try and encourage them to call me Jenny. They really have a tough time with that. So they end up calling me Professor, which makes me feel somewhat like I'm teaching at Hogwarts. I'm used to that, I just need like big cape that Snape wears. I am an assistant professor of astronomy. At a community college, that means that I've got tenure. So when you first start teaching, you're an instructor, and you get to call yourself an instructor. And then once you get tenure, you're an assistant prof, which is not how it works in the 4 years. And then after you've taught for 7 years, you get to tell the Senate, I've taught for 7 years. Can you call me an associate prof now? And they say, sure. And then after 12 years, you get to be a full professor. So it's basically the time you've been there, not really so much what you've been doing. I am an assistant professor of astronomy, which sounds kind of cool, except I'm the only full-timer at the school, which means I'm de facto the departmental chair. I get all the complaints, although I do have to say departmental meetings are pretty fun, pretty agreeable. I do have 3 adjunct astronomers that I work with. They're great people, but they have full-time jobs. They teach in the evening. One of them teaches during the day. So there's not too many colleagues around. I am also at the college the planetarium director, which also sounds pretty impressive until you realize that I do all the presentations, I troubleshoot all the IT issues, and I'm the custodian. If it's a planetarium related thing, it's me, because I'm the only one there. On campus, I'm also kind of the astronomy question, they will find me. If there's any student who wants to take an independent study class, build their own telescope, do whatever, astrophotography, they come and find me. If there's a public speaking prof who says to their students, you need to find an expert in the field, and then assigns their 3 classes of 90 students an astronomy topic, they all come to me, because I'm the only one with an office that they can find. So, teaching at a community college isn't just teaching in the classroom, you get a whole bunch of fun stuff to do as well. Now, where I work is at a community college. I happen to work at Glendale Community College, which is not far from here. This is where you are. Head straight uphill. Okay, well, you're, I guess, over here. Go uphill, take the 134 over, hang a right at the 2, and then the first exit. That'll take you out to Glendale. Zoom into our college. This is it. Got a lot of parking there, a lot of students. 22,000 students. And this, 22,000. This, yeah, that went up a lot in 2009. This is the planetarium. So that's my little home turf. It is a digital planetarium. It's also a classroom. So I get to teach in that classroom. Now, Glendale Community College is a really interesting place. It's similar to PCC. The student population is somewhat similar. We have a very diverse student population. We have students of all ages. So I do get seniors in my class that are taking it for credit. But we also have students of all abilities. So many of the students that you'll encounter at a community college have just managed to squeak through high school. They're not sure what they want to do with their life. They definitely don't want to go out and get a job, because that sounds like hard work. So their parents are encouraging them to take more school, so they end up at a community college. Many of our students are students like that. We also have people who just don't know what they want to major in college. So they'll come to a community college and literally take things from ceramics to math to the fire academy to electronics to astronomy to music appreciation, because we teach all of that stuff. We do, however, have a handful of students who are simply amazing, and I will get to stories about them in due time. But I think, how many of you seriously are interested at teaching at a community college, maybe to get some experience? So this probably is a slide that you'd be interested in. This is from Wikipedia, and it shows you, lovely old-fashioned pointer, what you can expect to earn if you're full-time. Now, that's the average. They kind of break it down here, how many people get whatnot. And to be more specific, if you're interested in Glendale, this I pulled from the Guild's, the union's website yesterday, and this is called the step-in column. So these are the columns, obviously. If you have a bachelor's degree, this is you. You guys are all over here, presumably, at either a PhD or master's plus a whole bachelor's plus a whole bunch of units. So you'd start somewhere up here, and then every year you'd get a raise, or you'd go up in step, and then you'd get whatever raises would be on top of that. So it's not certainly, I believe, what you get as a Caltech prof, but it's nothing to sneeze at. So that is kind of what you do. Now that's tenure stream or tenured. If you're teaching as an adjunct, you get about $3,500 a semester per class before taxes. Down here at the bottom, this is something that's interesting to note as well. I'm not sure if the adjuncts get this, but there is a stipend if you have a PhD. PhD in hand looks good to the college. They like that. They want to hire more PhDs and encourage more PhDs to come their way, so they give you a little bit of a financial incentive. So that's what we've done. So this is how I started. I found Glendale. They posted this position. I thought I would be interested in it, and they thought I was a good candidate, so they hired me. And then I got to GCC. My first day at GCC was in September of 2006. And I got there and I was so excited, I was so eager, I had to go to the bookstore and find out what my textbook was, because no one told me what textbook I had. Not particularly organized, our place. But I got there and I met with the division chair on the first day. And you know what he told me? He looked at me and I was all eager and I'm like, yeah, okay, I'm ready to teach. He goes, okay, lower your expectations. In fact, make them really, really low. And I thought, really? Damn. But that's what I started with. And I went from there. Now, I didn't actually believe him. And
I thought you were the department chair, you said you.
that's the, oh sorry, first year college, my first year astronomy class had 250 kids. So, by the end of the semester though, I mean, one of my classes had 21 students, the other one has 27. So there is quite an attrition rate, and I think that is typical for most colleges. The one thing you really need to know though, and I didn't fully appreciate this until I started teaching, is that there are no TAs. There is no one to help you with the grading, which sucks, because grading takes a lot of time. In fact, I say it takes 60% of your time. 40% of your time is spent teaching, and 60% of your time is spent preparing for class, writing your lectures, writing all the homework assignments, because no one's giving you homework assignments, writing the tests, figuring out what good questions are. To write a good test takes 4 or 5 hours. I don't know, is that still the case after you've been teaching for a while?
Oh, yeah.
Yeah, it's not, as a student, you don't appreciate the art of tests and grading. And I think one of my adjuncts said this best: the whole grading, getting ready for lectures, time spent outside the classroom really is an infinite time sink. You can spend every waking hour working on your lectures, perfecting them, getting them better, grading slowly, rereading this. What do they really mean here? Because you want to be fair to your students and things like that. So you can spend a lot of time on that, which means that there's not a lot of time for anything else. And that's okay, because you're not going to do a whole lot of socializing. At GCC, there's no coffee room or no lunch room to socialize. If you want to do any sort of collaboration, you have to consciously make that happen. Go out and find people to have these conversations with, talk to for me it would be talking to the physicists or talking to the chemists and see if we could have, astrochemistry seminars or things of that nature. So you really have to go out of your way to initiate. And when all your colleagues are so bent on getting all this grading done, they're, pulling them out of their office is kind of difficult. But there you have it. I have to say though, I do have great colleagues. They are really dedicated teachers. They're really great people. And the one thing I love about where I work is that between myself and my colleagues in the physical science division, there's a lot of friendship. There's no competition. It's not like I'm going to have more students than you're going to have, or what I'm going to get more grants than you're going to have, or better equipment. I mean, that's kind of a moot point. And it's all about the teaching and sharing teaching methods. And I have really great colleagues at the college when we actually do go out for coffee the odd time. So I kind of gave you a little bit of an overview of what it's like to work at a community college, and I'm going to head down now to my classroom and what I do in my classroom. First of all, having your own classroom is kind of like being your own boss, and that's awesome. It's lovely. You get to do pretty much whatever you want to do, and I get to decide for my students what is important and what they're going to study. Obviously, I'm doing stars and galaxies this semester. That's a big topic in 16 weeks. So I have to choose which details of which subject I'm going to emphasize and what I'm kind of glossing over and things of that nature. And if you ever thought you would be an awesome and a benign dictator, this is the place where you can do that. Because you can be that, because you're in charge. This is your classroom. And one of the things I would really encourage you to do is making that atmosphere awesome. Because the atmosphere of your classroom is really important. It's important to you because this is your workplace and you want to enjoy it, but it's also really important to your students. So the way I start my semester,
I just had a follow-up question on the last slide. So you said you can kind of decide what you want to teach. If you were in, say, physics or chemistry or biology, would there be more state-imposed requirements?
well, there is a curriculum. And there is a curriculum that says you have to cover, I do Kepler's laws, I do Newton's 3 laws of motion and gravity, and then I do, classifying stars and spectra, stellar formation, and stellar evolution, stellar death, and galaxies and cosmology and stuff. I mean, I do all of that. I, as an an astronomy student, love the whole stellar evolution. That's a passion that I have. So I kind of talk about how cool that stuff is. I mean, thermonuclear fusion, that's neat. So I can kind of share that passion with my students. But galaxies, sorry to people who are galaxies, they never really did much for me. So I can talk about the basics and how galaxies are classified. And we've done the galaxies zoo thing of having them go classify galaxies and things. And cosmology, I spend probably 3 weeks at the end of the semester talking about galaxies and cosmology. detail on stars and stellar evolution. So within the framework, you get to choose what you're going to do. If you want to teach a brand new course, because there are ideas to teach the history of astronomy or astrobiology or life in the universe, so to speak, it is a long process, about a 2-year process to go through curriculum and instruction to get that course approved. To get a course approved, to really teach what you want, you have to politically not step on the toes of the 4 years. So we're the 2-year colleges. We used to be the junior colleges. In 1967, they made us the community colleges. So I can't teach anything that is a 3rd or 4th year. I thought, oh, this is awesome, I can teach seminar classes, that'd be great. No. That's a 3rd or 4th year thing, and that's what the 4-year gets to do. I'm just a 2-year, I got to do the introductory stuff. And I'm like, okay, fine, whatever. So there are parameters in which you get to do whatever you want.
Well, aren't there some self-limiting parameters, like you probably can do very little with math in your class, I'm assuming?
Yes, I'll get to that. The math is interesting. The math is a huge problem for most of my students, but I'll definitely get to that. So for classroom environment, I like.
Does it take 2 years to get a course approved?
It can.
Why? Who is it that's deciding what the curriculum is that would take that long to decide on a course?
The committee.
I'm used to getting mad when it takes 4 weeks.
No, this committee. Everything moves.
What is their
smoothly.
function? What do they do?
Curriculum and
But for 2
instruction,
years.
it has to pass certain standards. We have to get it approved to see where it would be math-wise, and it has to be accredited. Like, it has to be able to transfer. I can teach whatever class I want, but if that is not a transferable class, either to the UCs or the Cal States, then no one's going to take it. Because at the college I'm at, most of the students are going for transfer. And so there's a lot of, you can make a class, but if UCLA and USC and Northridge and Pomona, which is where most of our students go, aren't going to accept that, what the hell? Students aren't going to take it. So me teaching is useless. So that's what takes long, because they have to talk to all these other places and make sure that it's approved. If you're teaching an upper-year seminar, basically you can come up with, I would love to do that, but that's not my job. That's your job. Enjoy.
Thank you so much.
Anyway, I like to set the tone for my class the very first day to let people know what kind of environment I am going to try to create in the classroom that we share together. So I will say things like, this is a welcoming environment, and you're going to accept that. And it is welcoming for everybody. Because if you specifically say things like the LGBTIQ students, who some view as kind of marginalized groups, then if you're accepting of them, then, oh, then she's going to be accepting of me too, because I'm not quite that in that group, or maybe you are, but if you specifically say you're welcoming to everyone, then everyone will feel included. So I have the little native populations little symbol up there, and then I have the little rainbow symbol up there to try and let people know that students of all ages and different abilities are welcome in this classroom. And I added all ages in this year because I got an 11-year-old in my class this year.
11.
I'll get to him. So my classroom, well, I try and make it a welcoming place and kind of a happy place, but it's a place of science, and I do stick to the science. But for many of my students, this science class they're here to take astronomy, but astronomy has geology in it, definitely has physics in it. We talk about this in chemistry and atoms and things of that nature. So it's just about any science you will think of. And for the bulk of the students in a community college science class, this is the last science class they are ever going to take, and it is probably the only science class they're going to take with an actual scientist. Because if you talk to them about the science classes they've had in high school or what they remember from grade school, they didn't have a good experience. So they come in and they have questions, and man, they ask everything. They want to know if aliens exist. I can't answer that question. We haven't found them yet. Maybe they do. So they want to know about astrology, if astrology is real. They want to know about vaccines. Don't vaccines give you the flu? Half my class thought that vaccines actually made you sick. I do talk some psychology to them because there are a lot of math phobias. And I acknowledge that. I realize that a lot of you don't like math. In fact, they're scared of math because I can see it in your eyes. And so if I address that, then they're like, okay, well, she knows. I don't have to hide it anymore. And then we can discuss it more openly. So I talk about everything, including the most basic science. I was somewhat appalled when it was my third semester of teaching when I realized by watching my students that when I talked about an atom and the atomic structure, they had no idea what I was talking about. So I kind of took a step back and said, okay, atoms. Have you guys heard of atoms? And they're like, yeah. And I'm like, okay, so what is an atom? You know, what's inside an atom? What is an atom made up of? Anyone know? And they're like, atomic stuff. And I'm like, good, yeah, right. Okay, so anyone heard of neutrons, protons, electrons? And they're like, oh, yeah. And I know, because my son's in 5th grade, that they learned this in 5th grade. But it clearly went right out one ear because they don't use it, they're never exposed to it again. So I have to talk to them about basic science, atoms. They're the building blocks of the universe. They're like Lego. That they get. If you can relate what they're learning to their everyday life, that's how you can help them understand what you're talking about. So, my classroom, I do get to experiment with new pedagogical techniques, new ways of teaching things. And over the years, I have kind of come up with a list of some things that I feel work pretty well in the classroom. And these are kind of the tricks of the trade. Now, the first thing I would recommend that you do is be happy. And I would say be all enthusiastic and be positive and be passionate about what you're studying. But some days that you're just too tired to do that. So if you can fake at least being happy, then that'll work. Because I actually talked to my students about effective teaching yesterday. And I didn't get them to write their names on purpose. But this student sums it up pretty well. Don't hate your job. It makes us hate the class. Clearly, the student has encountered a prof that hates teaching. And you're not going to like learning any subject if the person teaching it hates what they're doing. So try and be happy. That would be my first recommendation. The second one is if you're going to do PowerPoints, and students love PowerPoints, pick a friendly font. And this sounds like you're kidding me, but you know, if you pick a font that's a little unusual, and it gets, for the students, it gets pretty old pretty quickly. And they'll just stop reading it because it gets annoying. But for me, I can pick something cool and I'll just glance at it and then turn away because I'm not actually reading it. For them, they're reading it and then writing it down, reading it and writing it down. And you want to have something that is pleasing. So I've gone through a whole bunch of different fonts and I found this called Copperplate. I noticed a lot of you have Macs. It works well for presentations. My students like it and they can read it. Because it's printing, it's capital letters. I was writing something on the board one time and I actually had a student said, can you print that? I'm like, it's cursive, it's not like I have messy writing. But he couldn't read the cursive. So they probably couldn't read some of the fancier fonts as well. So capital letters works well. The next thing I'd say that I have found that works particularly well is changing the title color on the slides. So this title is in red. And that lets my students know that they can put their pencils down and then just listen to what I'm saying. Because for me, for the flow of the lectures, sometimes I have to put slides in that help me, you know, remember to talk about what I definitely wanted to talk about, but stuff that they don't necessarily need to write down. If the title's in green, that for them means, you know, red means stop, green means go. This works for them. And they can go ahead and write that down. Notice also that I've underlined the green title. I arbitrarily chose green instead of red because there's an amazing number of people out there who are red-green colorblind and they can't tell the difference. So things of this nature you need to be aware of. So that works. Other thing would be music. So music can be very effective if you get to a point in a particular lecture that you know your students are going to be, you know, falling asleep a little bit. You can always add a little music to wake them up. Really? It's a good way to have a bit of an intermission to wake them up. And you can use the music fairly my students are coming in, I'll just have music playing. I try and find theme music. I was talking about the Big Bang yesterday, so of course I had the theme music to the Big Bang TV show, which they really liked. A couple of weeks ago, I didn't have music. It wasn't working. I couldn't find the right thing on iTunes, and they came in. They're like, "Oh, it's so quiet in here." So they get used to the kind of environment that is a welcoming kind of nice environment to come into. Pictures and videos are also incredibly useful for helping people understand. Because if you ask your students, they are all visual learners. So I can talk about emission nebula or reflection nebula until I'm blue in the head. But if you have a really pretty picture, and all those that are in, you got to figure out where the lights are. There you go. So you really have a really pretty picture, and you can talk about the different colors and the different atoms that are producing those colors, and the Pleiades cluster you've got here, and then you've got, next one is M8, which is the Lagoon Nebula. Pictures are really, really important and very useful, and the students like them. And again, you can use them as a way of kind of breaking up your lecture. But videos are even more effective. Now, you can always pull animations off YouTube, and I link a lot of the YouTube videos to my class. But if you can't find anything you want, you can always just kind of wing it, as I call, and make your own videos. So I don't actually like seeing myself on video, so I generally have other people help me out with this. And the next little video, and I won't show the whole thing, just the start of it, but there are concepts, as I say, the basic science that my students either never got or it went in one ear and out the other, like convection, conduction, and radiation, the three methods of heat transfer. They don't get it, they've never heard of it. So that I did a little video on. But another one that over the years I realized that students just weren't grasping was the whole concept of differentiation. So I did a video.
I am Liam Krestow, Jenny's son. Now I'm going to be showing you differentiation. Out of these three liquids, olive oil, water, and corn syrup, we're going to be pouring them into this wine glass, only a little, and the one that is the most dense will sink to the bottom. It's a natural separation by density. Okay?
And you know, if an 8-year-old can get it, they're thinking to themselves, I can probably figure that out too. And I will say the number of students who on that final exam, the first semester I did this video, said, differentiation, it's when like the most dense stuff sinks to the bottom. Exactly like the corn syrup, if you mix corn syrup and water and oil together. And I'm like, of course they use that example. But it really hit home, something that was accessible to them. And that was, I did one take of that video with my son. He was really quite good. And it's usually a hit with the students. I have another one of my younger son. When you know one of those spinny rides at the park, and he stuck his bum way out, he went really slowly, and then he pulled it in, and it was like conservation of angular momentum, he went quick. That works well, also. So don't have to be professional videos. In fact, if there's any way that you can show the students that you are involved in this class as well, bring a little bit of yourself into the class. Tell a few tales about, you know, when the dinosaurs walked the earth and you were a kid. That kind of breaks up the monotony and helps them realize that you're kind of all in it together. So the next thing, and kind of the last thing in the tricks of the trade that I want to talk about is gauging your audience. Because I had a lot of comments in all of these that I got about people who talked about the profs, you know, kind of lecturing and just keeping them out there and not really connecting with them and not engaging with the students. If you don't know your students well, you can't talk with them. So you want to talk to them, you want to talk with them, but you want to make sure that you're talking with them, specifically that class, because you'll find when you're teaching that different classes behave very differently. And dynamics change all the time. It's not a little over here. So one of my students, this one, cue card, is, I mean, the grammar is incredibly poor, but he said, and this takes a while to figure out what he's talking about, don't lecture, just talk. So he didn't want me standing up there and lecturing, he wanted me kind of talking and communicating and having a conversation. And helping you understand the material, not just standing here lecturing and being this the sage on the stage and telling you about this stuff. This same student also said, struggle is important for learning. If you struggle with a subject and succeed, then that's the way that that's when you will learn the best. So, you know, the pearls of wisdom from your students. I actually poll my students all the time. If they've done particularly poorly on a test, I'll say, you know, guys, what happened? You know, the average is 54. What the hell happened, people? And, you know, they'll talk and and then, you know, I ask them, I said, okay, this is always the first test and the average is always really low. And I say, okay, how many of you studied for at least 2 hours? And most hands go up. And I said, how many of you studied for at least 5 hours? And I'd say 3 hands went up. I said, So I let them think of that. And I said, well, how do you think you could do better on the next test? Like, you know, looking at this test, was it a fair test? Did I spring any surprises on you? And they're like, no. And they come to the realization for themselves that, yeah, they should have studied more. Because 2 hours for a college test, just not enough. And that is having that conversation with them. And it's talking with them to help them understand what they need to do in order to do better in a particular class. So, you know, that's kind of what I've used over the years, what I found effective for teaching. But now I get to kind of go into the few tales from the trenches. And we're here until 6, right? 5:35, 6, how long does this go? Okay. So the first one is great. I talked to my students at the beginning of the year. Every semester I talk to my students and I tell them the importance of vocabulary in science. In science, words have a specific meaning, right? And the force that holds the planets in orbit around the sun is not great. Because that is the answer I got on a test. And I'm fairly sure this individual meant to write gravity, but 3 places on the same test, the same student wrote gravity. And I'm like, okay, I can't, I'm sorry, I can't give you the point. And I brought this up with about the test when I was handing it back. And it is comical until you realize that there's something missing, that one student, and I talked to him afterward, and he goes, well, you know, they're like the same. And I'm like, not the same enough. Gravy is that goopy stuff you put on turkey, Thanksgiving, gravity is of course, the universe.
Food at each lecture.
What's that?
You need to serve more food at each lecture.
Clearly, I do. Well, in the planetarium, there's no food or drinks in the classroom, so they have
That's
to leave
the
it
problem. Now we've identified.
So the next kind of topic is a couple equations here. We have F equals ma and E equals mc squared, and we talked about the lack of mathematical ability. Now you guys are at Caltech, fairly sure you're good at math. But the first real encounter that I had with people's lack of mathematical abilities is they just leave questions blank on the test. They just wouldn't attempt the math questions. And they're questions like, if it's a 10-kilogram mass that was accelerated at a rate of 5 meters per second squared, what's the force? And what force would be necessary? It's not difficult. Algebra. But it's that phobia, that just, it's math, I can't do it. But one of the things that I encountered that I realized is there are some people who it's been so long ago that they've done math or they've blocked math out so effectively that they just have issues. So I had written F equals ma on the board, and we were going to isolate the acceleration. So I was kind of going through all the steps that you students have to do. So you divide each side of the equation by m, and then you have a is equal to f over m, and that's how you set up the equation. And the students are like, okay, so I did it where you isolated m, f over a. And this is the type of thing that you have to do, because for many of them, they hadn't taken math in a few years, and they didn't like it when they were doing it, and they didn't see the need for it. But I had one student who came up after class, and power to him for feeling comfortable enough to come and talk to me, and for wanting to be able to figure this out. But he looked at this and he goes, so this f over m, it's been a long time since I've done math. Can you just remind me, is that multiplication or division? So I'm thinking to myself, are you kidding me? And then I had this brilliant idea. I said, well, you know, do you see this line here? And there's something on the top, and there's something on the bottom. It's division. And he's like, okay, great, thanks. You can do the homework. And I'm just like, okay, that was kind of a new low. But that's the type of student that you can get at a community college, so be aware of that. The other thing is we were doing thermonuclear fusion, and we used E equals mc squared to figure out how much energy is produced when you have 4 hydrogen nuclei fused into 1 helium-4 nucleus, and that has a loss of mass. The helium-4 has less mass than the 4 hydrogen, and that mass loss can be converted to energy, and you can figure out how much energy you use in this equation. So I said at the end of the lecture, and the students are just beginning to pack up and head out, and I said, you know, you can go home this weekend, you can tell your family that you and Einstein, you get Einstein, you're like this. And there's one student going, whatever. And I looked at him and I said, what? He goes, yeah, I'm gonna get a smack on the side of the head.
What, you think you're better than me?
My dad won't be impressed. That was another instance that did use some math, but that led me to the realization that while you hope every student has a supportive environment, that their family is saying, you know, you're going to college, that's great. The reality is very different for many students. Possibly not at Caltech, because I don't know many of you would be here if you didn't have a supportive family, but at our college there are people who are there in spite of their family. And I was upset about that. I think I probably got more upset as the weekend went on, realizing that this guy, he's trying to get a college education and do something, and he can't even talk about that with his family because they'll think, you know, he's trying to one-up. So that was another realization, you know, things that you learn when you're teaching. Brandon and Warren, 3 years ago I had Brandon as a student of mine. He was 11 when he came into my class. Very quiet, sat there quietly, no problem. Came, did very well, got an A, left. He was taking a UCLA class. He was in Calculus 3 at the time, so clearly a very bright student. But I didn't know much of his story. But this semester, I got another 11-year-old called Warren, and I have been talking with his mother. He clearly is a gifted student. They took him out of the public school system and they put him into private school. That didn't work for him. They took him out the mother homeschooled him for a couple of years, but she tried to get him into Walter Reed, which is a high school for gifted, Midland High School for gifted kids, and he didn't test well. He didn't do the multiple choice tests well. If you don't test well, you're not going to get in. So he didn't get in. So she's trying to figure out what on earth to do with this really bright kid who's having conversations with the speakers up at the JPL, you know, the Von Karman lectures, I think they are. And she was taking a class herself at GCC, and she had talked to a colleague of mine in geology and myself, and I said, well, you know, if he wants to come and take my class, I have no problem with that. And she's like, well, you know, I hope he's not disruptive. And I said, well, if he's really interested in the subject matter, the only way he's going to be disruptive is asking a question, and I really encourage questions. So that's not going to be a problem either. He's been an exceptional student, and for him, this experience has been extraordinary because he has said to his mother that this class is awesome. His exact words. Because finally he was at a class that didn't slow down, that didn't repeat everything 5 times over, which you do at the lower levels. That it was going at a pace that he liked. And this is a kid who's now going to have an opportunity to take both a math class and a physics class in the fall and be in an environment that intellectually challenges him. Now, he is a decade ahead of many of my other students, but that's what you get at a community college, and that's kind of what I love, because you have some of these stories of people who are really struggling, and then these stories of people who are just blossoming and taking off. Because Warren is a neat guy. He did chemistry experiments in his garage for a couple of years, but now he's moved on to astronomy and physics. So, other tales from my classrooms. Mario is I don't know if he's a senior. I don't know what technically a senior is. I think he's in his late 50s or 60s, and I'm not quite sure why he's there because he's got a full-time job. But he's taking my astronomy class, and he is probably the perfect student that you want because he's an educated guy. And the thing about him is he's not actually scared to ask questions where so many of the people you know they have a question, but they're not gonna say it. Mario will ask, and one of the first days of class, he said, I have a silly question. I said, no, there are no silly questions. There are questions, and they may not be pertinent to the topic, but ask away. And the question he had was a great question, and I said to the rest of the class, I said, was that a silly question, or were some of you thinking that? They're like, well, that's a good question. And so he's being kind of this little bubbling pot of questions throughout the whole semester. And for him, watching how the answers I give change his understanding of the universe is amazing. Because we started talking about cosmology, and cosmology, you gotta understand in my class, is very basic. And we started talking about the whole universe. And he stopped me, he goes, I have a stupid question. I said, it's not a stupid question. Because he keeps saying this, he prefaced everything with that. And he said, so nature, like rocks and trees and running rivers and mountains, he goes, is the whole universe made of the same stuff? And I said, yes. So he goes, it's a natural universe. I'm like, yes. And this was huge for him. The fact that the universe was the same stuff. I said, it's the same atoms. Rock is primarily silicon dioxide. You go to Mars, you go to the moon, you're going to have a lot of silicon, a lot of oxygen up there. Combined together as molecules, and it's the same everywhere. And this blew him away. And his enthusiasm for the subject, and everyone's turning and watching him, and he's just like, whoa. And then you can see the other students beginning to think the way that he's thinking. So he's a great catalyst for this exploration and kind of the more profound thinking than you might get in a class. So I love people like Mario, and anyone who asks those type of questions, I would really encourage you to answer them as best as you can, as fully as you can, because those will make a huge difference, not only to him, but the other half of the class who are thinking similar things but aren't going to ask because, they're still 19. They don't want to stand out in a crowd. So I kind of started at the grievous end, and now I'm kind of working toward the good end. I'm not going to talk about Santos, but there are some other students that I kind of want to touch base on. Laura and Anush are both students of mine, former students of mine, who got A's in my class. Both of them are now up at the Griffith Observatory as museum guides. They liked the class sufficiently, and they found it so interesting that they've actually gone out and got a job in the field. And there aren't too many astronomy jobs out there, but the Griffith pays well for students. It's almost $14 an hour. So these two, they both transferred to Cal Poly Pomona, and really happy that the class that they took actually had some effect on their life. They could get a job with the knowledge they learned at the class. And both of them have come back and said that they wouldn't have got that job if they didn't have the knowledge that they learned at school, which is kind of satisfying. Elizabeth is another student. So Elizabeth and Torgum and the Dome guys are kind of the exceptional students. I said at the beginning that there's a handful of students that we get that are just amazing. And you're wondering, I was wondering, what the hell are they doing at a community college? Like, why didn't they just go to Berkeley in the first place? Very astute people. They come to a community college to save money for 2 years. Because a year at a community college is about $1,600. A year at UCLA or USC is, I don't know, tens of thousands. So Elizabeth came to GCC because she didn't know what she wanted to take. And she did take a course at the Fire Academy, and electronics, and ceramics. She took music, high school, he didn't work. He got a 3.9 average, but he didn't know what he wanted to do. He was thinking maybe he'd do construction because he liked making things. So at the beginning of high school, he said he wanted to be like a general contractor. And then by the end of high school, he's like thinking, oh, you know, maybe I could be an architect. And then he came to community college and he discovered the physics program and the physics engineering. And he thought, you know, I bet, you know, I could be an electronic technician. And then he started working in the planetarium, and I got to know him really well, and I'm thinking, this is a smart guy. And I said, Tori, have you ever heard of Caltech? He's like, well, east of here, isn't it? And I said, you know what? You're good in physics. Maybe you should think about considering transferring to Caltech. He found out 2 weeks ago he was accepted for transfer to Caltech. He's one of 6 students accepted for transfer. So he went from thinking he was going to be a general contractor, now he wants to be an electrical engineer. And he will do it, because he's awesome. But the other guys in the dome see him and are inspired by him and are heading in that general direction as well. So you think, you know, the community colleges, you know, you're not going to get some good students, and you do have a lot of students that have issues with math and vocabulary and grammar and the English language, and they're not the ESL students. They actually have much better grammar. But you get some interesting characters, some that take your lessons from your class and just fly with them, but then you get the few that are just what make teaching absolutely worthwhile.
I just want to add that they work for me. The film people, they work for me at Carnegie, and they are like ridiculously good. And they work so hard. They're like, I don't know, they work much harder than I ever did at university. And Elizabeth, we were very sad when she left. We keep trying to get her back, but she's like, no, I don't want to do astronomy anymore.
Yeah, sad. But they really are some good, and they don't know how good they are.
Yeah, they have no idea.
Until they come to a community college and realize that they can do this, because we have a robotics academy. And in a community college, it's a little bit low pressure, because if you take a course and you don't like it, you can drop it, because the whole course was like $60. Actually, no, it's $120. But it's not like you're going to UCLA and there's a lot of pressure because of all the financial, you know, baggage that comes with to go to a four-year college. So a community college is an amazing place to teach, and you do really get some people that you can inspire and that you're inspired from in return. So a couple of recommendations I would say to anyone who would be interested in teaching. One is do what you love. Hopefully if you're going to teach, you're going to do it because you love it. Be engaged with your students. Don't be, you know, out here, talk to them. I always, Monday morning, I'm like, hey guys, how's your weekend? Anyone do anything cool? And I had one student say, I got engaged. So we all like stood up and thought, yeah, you got engaged. So, you know, people have interesting lives. And you don't have to do much beyond that, but make them feel that, you know, this is part of their life and they should enjoy it. Be realistic. One of my adjuncts said this, you know, have reasonable expectations. If you think you can make every student into a passionate astronomy buff or biology buff or physicist or whatever, that's not going to happen. But if you hope to really reach 1 and 2 in each class, that probably will happen. And if you can make the rest of the class more science literate, that is great. That is what is really fulfilling. So kind of in conclusion, teaching as a profession is incredibly time consuming if you do it well. Often it's thankless, but you can have these incredibly rewarding experiences as well. So that's it for the talk. I always have the end slide. People really like that. And then I always have music kind of to send people on their way. So if you do have any questions, now would be a great time, or you can always email me. If you're thinking of, you know, if you want to give a guest lecture at the college, if it's not in astronomy, I can probably set you up with someone in the physical sciences or the biological sciences. If you want to teach a course, we're always looking for good adjuncts, so talk to me about that too. But there you go. If you have any questions, you were very quiet during the presentation, but if you have any questions, now would be a great time.
For either you or just your colleagues in general at community colleges, it sounds like you come in often with a background, either a master's or a PhD in your science. Is it common to have a coursework background in education, like a master's of education, or not?
If you want to teach in like a science, you need to have at least a master's in that, what's called a faculty service area. So I have faculty service areas in physics and astronomy and geology because of my geophysics master's. So that I could teach any of those. If you only had a degree in education, you could teach in the, like kind of the education component. Maybe you could teach some psychology and the psychology of education, but you would need a master's at least or a PhD in the specific area in order to teach that area.
Right.
But the whole, the doctorate stipend, I think, is either PhD or ED.
Okay.
So you don't need a credential, is what he was asking. For teaching at a community college.
What do you mean by credential?
A teaching credential?
No. You don't need to be a certified teacher. No. I actually looked into going to get my teaching credential because I really like the 3rd grade age level, and I'd have to take like 2 more years of college. I'm like, oh, I'm so done with college. It's not gonna happen.
How does maths work? Because I know in England I can't teach maths, even though I have a PhD in physics, because apparently they're not the same. But like, could I teach maths here?
It actually goes down to what math courses you took and how many math courses.
Right.
So they'd have to look at your actual transcript, and if you're bringing a transcript in from any foreign nation, it has to be, what's the word they used? Translated?
Yeah, I have to get it translated.
So, I came in from Canada, and, they've heard of the University of Toronto, but they didn't know if it was a real university. So they had to make sure it was real, and make sure that a PhD or a master's at the University of Toronto was the equivalent in Canada, or in America, which, they blanket statement do that, because, you can have great universities, I don't think that Oxford and Cambridge, they've heard of, and they're probably pretty sure that the PhD there is a good PhD, but there's somewhere in Romania or Kazakhstan or Russia, there's some excellent schools in Russia, but everything's written in Russian. On the transcript, you don't know, does this say masters? I don't know. So you take it to a translation service, which translates the language as well as then translates what the coursework actually means. And that's on you, it costs $200 to do that. So, fun, wow.
Do you find it, how do you go about pacing your classes so you're not leaving behind people, but you're keeping sort of people interested as well when you have such a broad distribution of backgrounds?
That is one of the hardest parts, because I don't want to lose Torgum, because Torgum's actually in my class this semester. I don't want him to get bored and sit there, if he's not bored, that means I'm losing some of the low end. So I try, and I have a website, and the website has all of the readings that we're going to do for the entire semester. It also has a link to websites that are appropriate for the material. And I said, if you're struggling to keep up with class, do the readings beforehand. Go to the websites beforehand. And I do have students that do that. Now, the really low-end students who are kind of flaky anyway, they've dropped my class. And they do drop. And I'm kind of in 2 minds for that. I kind of feel guilty, but no, not really. Because they know what they need to do well, and they haven't been doing it. A lot of them don't know how to. Because, quite frankly, I talked with my one class for about 45 minutes yesterday about best practices. And I said, you guys, you don't know what an atom is. Like, I have to review that. Like, what's with this? And from their perspective, they say what they learn in high school is very little because of discipline issues in the high schools. That the teachers can't teach because they're constantly telling this guy to sit down, and why haven't you doing your homework? Like, it's just, the one guy said, Arden said it was a circus. His science class, there was he goes, I'd like to learn. I think the teacher was okay, but that never happened because of the people in the school. Now, those students who got D's, well, some of them have come to community college, but generally they don't even come to a community college. So you kind of got, the students I get in my class are at least respectful of having that class environment. I've had other people who say, anyone who's on their cell phone, kick them out. And the students are pretty forceful about this, pretty aggressive about this. They don't want to be distracted by anyone else, Facebooking or texting or whatever. They're really quite strong about that. So there's a fine line you have to walk between being accessible and approachable and passionate and enthusiastic and kind of setting a nice tone in there, but you know, you guys, you're talking. So can you just take it outside? Thanks. When you're done, you can come back. So you have little things like that. But for the people who are really struggling, I make it very clear when office hours are. I also tell them, you know, if they've done poorly on a test, I'll write a little note on the bottom of the test, you know, please come see me in office hours tomorrow at 2 p.m. I'll be waiting for you. And if you tell them you'll be waiting for them, they feel guilty, they show up. So, but I mean, that's tough to do when you've got 150 students. So you kind of have to, this is what I say, you gotta be reasonable and figure out, pick your battles. So.
Kind of following up on the topic of students who drop the class, like you said, most students are here to get presumably good grades and then transfer to a four-year